Dear students, welcome back. In the previous session, we have discussed about the ligaments of the wrist complex. Now in this session, we are going to discuss about the function of the wrist complex. This wrist complex includes two compound joints, that is radiocarpal joint and midcarpal joints, and how the movements of this radiocarpal joint and midcarpal joints are taking place. Okay. Now, what are the movements of this wrist complex? Or one is the wrist flexion, wrist extension, and radial deviation and ulnar deviation, and some amount of supination and pronation is also taking place during these movements. Okay. Now, what actually happens during this movements? That is the arthrokinematics. How these movements are taking place. This one is a very complex thing, okay, and also this corporal kinematics is also very complex when compared to any other joints. So this corporal kinematics is a complex thing, and so many studies have been studied to understand this kinematics. Finally, they given their investigations as the complex kinematics are present in the case of wrist complex movements. Although we have to understand how the movements are taking place. For that, they have designed a concept framework to understand this basic movements, how it is taking place during flexion and extension and radial deviation and ulnar deviation. How these corpels are moving during this motions. They have given a concept. Okay. So before studying their studies, just we have to understand the basic thing of these movements. One is the movement of the radiocarpal joint is predominantly a gliding of the proximal carpal row on the radius, proximal carpal row on the radius and the radio-ulnar disc. Because of the convex surface of the carpals move on the concave surface of the distal radius and ulnar disc, radio-ulnar disc, the glide of the proximal carpal row occurs in a direction opposite to the movement of the hand. So here the gliding of the proximal row occurs in the direction opposite to the movement of the hand. For example, if you take the wrist flexion, the carpals will slide dorsally. The carpal will slide dorsally on the radius and disc. While in ulnar deviation, if you take in ulnar deviation, in the case of ulnar deviation, the carpals will slide radially. The carpals will slide radially. So here the major ligaments and in some instances some bony structure check each slide at the end of the radiocarpal range. So some of the ligaments and the bony structures are going to stop the movement when it reaches the end range. If in the case of radial deviation, the ulnar side of the proximal row is checked. Ulnar side of the proximal row is checked when the ulnar collateral and a less extent of ulnar carpal ligament becomes taut. So this is the limiting point. Whereas in the case of radial deviation, so in the case of a radial deviation, it was checked by the scaphoid, which will impact on the styloid process of the radius. Okay, and also the ligaments and the bony configurations are the only checks to the radiocorpal range, and this may be vary from individual to individual, which can alter the permissible range to a considerable extent. So we are having some degree of range of ulnar deviation and the radial deviation, so, and also flexion and extension. Because of some changes in this ligaments and this bony structures, the range of this movements may increase or decrease beyond the range from individual to individual. Okay, so this thing you have to keep it in mind. And motions at the radiocorpal joint are caused by, instead of, combination of active and passive forces and also joint reaction forces. Although there are abundant passive forces on the proximal carpal row, there is no muscular forces are applied directly to the articular bones of the proximal row. And the only muscle, the flexor carpi ulnaris muscle, applies its force via the pisiform bone to the more distal bones. Although this pisiform will not included under this radiocorpal joint. So this is an exception, so which is having some attachment with the flexor carpi ulnaris. Okay, and then so because of this thing, Guilford and Associates suggest that the proximal carpal row is an intercalated segment. That means it is a relatively unattached middle segment of the three segment linkages. Three segment here, the radio-ulnar and the distal carpal, and this one becomes the middle segment. This middle segment is called as intercalated segment. When compressive forces, and this Guilford and Associated studies are hypothesized by Ruby and Associates that the proximal row, which functions as an intercalated segments between distal radius and triangular fibrocartilage complex, and the relatively immobile distal row. So they have also mentioned the same point, and they also mentioned that when compressive forces are applied across an intercalated segment, the middle segment tends to collapse and move in a wrong direction, and this middle segment are going to collapse and move in wrong direction. That means the proximal carpal row will crumple and move in the wrong direction when compressive muscular forces were applied across the radiocarpal and midcarpal joints. So some type of stabilizing mechanism is required to normalize combined midcarpal and radiocarpal motions and prevent the collapse of the middle proximal carpal row between the distal radius and the distal carpal row. Normally, the stabilization mechanism would occur by the intercarpal bridge provided by the scaphoid and the wrist complex ligaments. Okay, so these are the things they have identified. Okay, and by taking these studies, another investigator called Garcia Elias supported this hypothesis that the stability of the proximal carpal row depends on the interaction of the two opposite tendencies when the carpals are axially loaded. Okay, so during this thing what will happen? So normally this axially loaded means compression across a neutral wrist. When we called it as neutral wrist, when the third metacarpal, when the long axis of the third metacarpal comes straight with the long axis of the forearm, then it is called as neutral wrist. In that position, if you give some axial compression, the scaphoid tends to flex. The scaphoid is going to flex, whereas the lunate and triquetrum tend to extend. Okay, and these counter rotations within the proximal row are prevented by this ligamentous structures such as scapholunate interosseous and luno-triquetral interosseous ligaments. Okay, and also linking the scaphoid to the lunate and triquetrum through ligaments will cause the proximal carpals to collapse synchronously into flexion and pronation also. So, which also causes flexion and pronation, whereas the distal carpals move into extension and supination. Okay, these counter rotations are proposed by this Garcia Ellis, and the resulting ligamentous tension, which increase the adaptation, we can call it as adaptation, or the distorted this carpal bones are drawn together by these ligaments of the midcarpal articular surfaces, and finally these ligaments add to stability. Okay, these are all the findings done by this Garcia Elias, and he is the person who proposed this concept framework, okay, conceptual framework, and findings of other investigators differ in detail, if not in substance. Advances in technology, including computer modeling, suggest that intercarpal motion is far more complex and individualistic than was once thought. Okay, so however, how many studies we have did, which proves always this carpal kinematics is very complex. But there is a general agreement that the three bones of the proximal carpal row do not move as a unit, but the motions of the three carpals vary both in magnitude and in direction with axial loading, with radiocarpal flexion, extension, and also with radial and ulnar deviation. And another investigator called Short and colleagues found that carpal motions differ not only with the individual osteoligamentous configuration and position, but also it varies with the direction of the motion. That is, in relation with the corpus differed when the wrist reached neutral position, depending on whether the position was reached from full flexion, full extension, or deviation. Okay. So, like that, so many studies have been coming up, but the controversy remains. In terms of the existence of an actual center of rotation. So, on which center of rotation of the wrist complex all these movements are taking place. And much of the literature proposes that the head of the capitate, frequently referred to as the keystone of the wrist, and may serve as the location of coronal axis for wrist extension and flexion, and AP axis for the radial and ulnar deviation. Okay. So this forms the the capitate bone forms the center of rotation based upon literatures. And New and associates studied that the kinematics of capitate with wrist motion in both planes concluded that the axis of motion is not constant always. Okay, so this proves that again the corporal kinematics is very complex. So finally the studies have proved that the corporal kinematics are complex. For basic understanding at this stage, we have to consider the conceptual framework and capitate as center of rotation to understand the movements of flexion and extension as well as the radial and ulnar deviation. Now, the first movement which is taking place in the wrist complex or the flexion and extension of the wrist. Now we are going to study this movement according to the conceptual framework. So in this conceptual framework, so first the wrist is moved toward extension from a fully flexed position. So we have to understand the movement of wrist extension and keep the wrist in fully flexed position. Okay. And the main aim of this conceptual framework is to understand the movement. However, this concept oversimplified and ignores some of the other simultaneous interactions that occurring by the key corporal bones. Key corporal bones means here. So during these movements, there are, though we are having 8 corporal bones, there are some corporal bones which are active during this movement. Those corporals are called as key corporal bones. Okay. Now we are going to see the sequence of events for understanding of the relative motions of the various segments during extension of the wrist from fully flexed position. Okay, now the first step is extension is initiated at the distal carpal row. So extension is initiated at the distal carpal row with capitate at its center. So capitate bone is the center of rotation. Okay. Now, and also during flexion and extension of the wrist, the scaphoid seems to show the greatest motion of the 3 proximal corporal bones, whereas the lunate moves least. And capitate as the center. Okay. So that means the 3 corporal bones become the key corporal bones here. Okay, what are the key corporal bones? Capitate, scaphoid as well as the lunate. Okay, now the first step is extension is initiated at the distal carpal row with the capitate as its center, and the second step is the mid-carpal motion occurs with the distal carpals. So mid-carpal motion occurs with the distal carpals gliding on. So very important here. The mid-carpal motion occurs with the distal carpals gliding on the relatively fixed proximal bones. So relatively fixed carpal bones. Now only the distal row is moving. There is no movement in the proximal row as well as in the radiocarpal joint. Okay, only the movements in the distal carpal rows is taking place. That is called as mid-carpal motion, which occurs with the distal carpals gliding on the relatively fixed proximal bones. What are the proximal bones? Scaphoid, lunate and triquetrum. So, although the surface configurations of the mid-carpal joint vary from carpal to carpal, the orthokinematic movement appears to occur most commonly as glide. So, the orthokinematic movement appears at this stage is gliding. Okay. So, what gliding of the distal carpal row in the same direction of the movement of the hand. So, here the gliding of the distal carpal row in the same direction of the movement of the hand. Okay. So, the hand is also moving in direction and the distal carpal row is also moving in this direction. Okay. So, this is the second step. Okay. Now, coming to the third sequence, when neutral wrist complex position is reached. So, what is the neutral wrist complex position here? So, I have already mentioned what do you mean by neutral wrist. That is the long axis of the third metacarpal bone is in line with the long axis of the forearm. This is called the neutral wrist complex position. So, at this position, what is happening? So, once it is reached to this position, what is happening here means the ligaments spanning the capitate and scaphoid. So, that means the ligament between the capitate and scaphoid here. Okay, what it is going to do? The scaphoid draw the capitate, the capitate and scaphoid together into a closed pack position. So, the scaphoid drag capitate onto the scaphoid to form a closed pack position. Okay, this is the third step. And continued extensor force. Now here still the muscular forces. The continued extensor force now moves the combined unit of the distal carpal row and the scaphoid on the relatively fixed lunate and triquetrum. So here very important. So what is happening? So the scaphoid and capitate forms a closed pack position. So this capitate is present in the distal carpal row. So further extensor force causes the movement of this distal carpal row. Here what is happening? So the scaphoid also involving here now. So along with the distal carpal row with the scaphoid is moving now, is gliding on what? On lunate and triquetrum. Lunate and triquetrum. Okay. At approximately 45 degrees of hyperextension of the wrist complex. Next point. So, when it reaches to approximately 45 degrees of hyperextension of the wrist complex, what will happen? The scapholunate interosseous ligament, that means by the side of the scaphoid, it is having lunate bone, isn't it? So the scapholunate interosseous ligament brings the scaphoid and lunate into closed pack position. So then what will happen here? So already the distal row with scaphoid forms a single component. Further, at this hyperextension stage of 45 degrees, so what will happen? The scapholunate interosseous ligament bring the scaphoid and lunate into closed back position. So what will happen? This unites all the carpals and causes them to function as single unit. So because of this, all these carpals are going to work as a single unit. Okay, next point. Wrist complex extension is completed as the proximal articular surface of the carpals move as a solid unit on the radius and radio-ulnar disc. Now once it happens, all these carpals are going to be a single unit, and this proximal row is going to glide over the this one proximal articular surface, the distal articular surfaces of the radius and the radio-ulnar disc. Okay, so all ligaments become taut as full extension is reached. So at this stage what will happen? All ligaments become taut as full extension is reached and the entire wrist complex is in closed back position. Okay, once this closed back position occurs, that means the entire extension of the wrist is completed. Okay, these are all the various steps which are taking place in the movement of extension of the wrist. Okay, so if you see all these movements, here the scaphoid through the mediation of the wrist ligament participates at different times in scaphoid capitate, scaphoid lunate or radioscaphoid motion. And crumpling of the proximal carpal row, that is intercalated segment, is prevented and full range of motion is achieved. Okay, the wrist motion from full extension to flexion occurs in the reverse sequence. Okay, these are all the sequence which occurs during flexion and extension of the wrist. The next one we are going to see is the radial and ulnar deviation of the wrist. Okay, so what will happen during this radial and ulnar deviation? So in the radial and ulnar deviation, in radial deviation from neutral position of the wrist complex, the distal carpal row moves radially. The distal carpal rows move radially on the proximal row until ligamentous and bony structures lock the rows together. Okay, so that means, so the distal row is moving towards the radial side. Okay. Continued force toward radial deviation would appear to cause the carpals as a unit to slide ulnarly. That means to slide ulnarly on the radius and radio-ulnar disc. And some investigators believe that the radiocarpal motion is negligible here. And it has been found that both the scaphoid and lunate is going to flex during radial deviation. These two bones are flexing during radial deviation while the distal carpal row extends. Okay, and it is hypothesized by that the opposing extension flexion motions of the carpal rows that occur with radial deviation permits the carpals to accommodate the narrowing space between the styloid process and the trapezoid. So here this is the narrowing space. Okay, in full radial deviation, both the radiocarpal and midcarpal joints are in closed back position. So during full radial deviation, in full radial deviation, both the radiocarpal and the midcarpal joints are in closed pack position. So this is the things happening in the radial deviation. In the case of ulnar deviation, from the neutral wrist complex position, active and passive forces move the distal carpal row ulnarly. So active and passive forces move the distal carpal row ulnarly. Okay, until it is checked by ligaments. Here the hamate is simultaneously pulled proximally, causing the proximal carpals to spread and slide radially until checked by the radial ligaments. Okay, ulnar deviation occurs at both the midcarpal as well as the radiocarpal joints. Although some investigators have found that ulnar carpal motion, so that is radiocarpal motion, to predominate. As in radial deviation, the proximal and distal carpal rows again move in opposite directions in the sagittal plane, while ulnar deviation occurs. The scaphoid and lunate extend. The scaphoid and lunate, these two bones are going to extend, while the capitate and the trapezoid and trapezium are going to flex. So in the radial deviation, it is opposite. Okay. Yes. The ranges of wrist complex, radial and ulnar deviation are greatest when the wrist is in neutral flexion and extension. When the wrist is extended and is in closed pack position, the carpals are all locked and very little radial or ulnar deviation is possible. In the case of wrist flexion, the joints are loose packed and the bones are free. Further movement of the proximal row cannot occur as in extreme extension. Little radial or ulnar deviation is possible in fully flexed positions. So these are the movements of the carpal bones which are taking place during radial and ulnar deviation as well as the wrist flexion and extension. In the next session, we are going to see the wrist instability, which are also considered under the function of the wrist complex. In the next session, we are going to see the wrist instability. Thank you.